Hello and welcome back to Saxon Math. This is lesson 89, estimating square roots. We have practiced finding square roots of perfect squares from 1 to 100. In this lesson, we'll find the square roots of perfect squares greater than 100. We will also use a guess and check method to estimate the square roots of numbers that are not perfect squares. As we practice, our guesses will improve and we will begin to see clues to help us estimate. So for example, for the square root of 400, all you can do is guess and check in many cases. So in this, we might guess that 10 times 10 equals 100. Therefore, the square root of 100 equals 10. So square root of 100 equals 10. That's not quite enough. So 10 times 10 doesn't work. 20 times 20 might be something that we could look at. 20 times 20, that equals 400. That means that the square root of 400 is actually equal to 20 because 2 times 2 is 4 and then 2 zeros makes 400. So you just need to find a number that when multiplied by itself has a product of 400. We know that the square root of 400 is more than 10 because 10 times 10 equals 100. We also know that the square root of 400 is much less than 100 because 100 times 100 equals 10,000. Since the square root of 4 equals 2, the 4 in the 400, or square root of 400, hints that we should try 20. 20 times 20 equals 400. So let's simplify the square root of 625. In example 1, we found that the square root of 400 equals 20. Since 625 is greater than 400, we know that 625, or the square root of it, is greater than 20. We find that the square root of 625 is less than 30 because 30 times 30 equals 900. Since the last digit is 5, perhaps the square root of 625 is 25, and you can multiply to find out. 25 times 25 ends up being 625. So we have practiced finding the square roots of numbers that are perfect squares. Now we will practice estimating the square root of numbers that are not perfect squares. So in example 3, between which two consecutive whole numbers is the square root of 20? So notice that we are not asked to find the square root of 20. To find the whole numbers on either side of 20, we can first think of the perfect squares that are on either side of 20. Here we show the first few perfect squares starting with 1. 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, and 7 times 7 is 49. We see that 20 is between the perfect squares 16 and 25, so the square root of 20 is between the square root of 16 and the square root of 25. Since the square root of 16 is 4 and the square root of 25 is 5, we see that the square root of 20 is between the numbers 4 and 5 squared. So you can see those would be the two consecutive whole numbers. Using the reasoning in example 3, we know that there must be some number between 4 and 5 that is the square root of 20. So we try 4.5. 4.5 times 4.5 would end up being 20 and 25 hundredths. We see that 4.5 is too large, so we try 4 and 4 tenths. 4 and 4 tenths is 19. When you multiply it by itself, is 19 and 36 hundredths. We see that 4 and 4 tenths is too small. So the square root of 20 is greater than 4 and 4 tenths, but it's less than 4 and 5 tenths. It's going to be closer to 4 and 5 tenths. If we continue this process, we would never find a decimal number or fraction that's exactly equal to the square root of 20. This is because The square root of 20 belongs to a number family called the irrational numbers. Irrational numbers cannot be expressed exactly as a ratio, that is, a fraction or a decimal. We can only use fractions or decimals to express the approximate value of an irrational number. So the square root of 20 is approximately 4 5/10. This wavy equal sign means approximately, or close to it. The square root of 20 is approximately equal to 4 5/10. So if we're to use a calculator to approximate the value of the square root of 20 to 2 decimal places, you can clear the calculator and enter the square root of 20 or 20 square root. The display will show 4 and then 0.472135955. The actual value of the square root of 20 contains an infinite number of decimal places. The display approximates the square root of 20 to 9 or so decimals depending on the model calculator that you have. We are asked to show 2 decimal places, so we round the decimal or the displayed number to 4 47/100ths. If we were to round to the 2 decimal places, you can see this is a 2 after it. The 7 remains the same. So the approximate value of the square root of 20 is 4 47/100ths. And if you took 4 47/100ths times 4 47/100ths, you would approximately get 20. All right, let's try each of these. Find the square root of 169. So in order to do that, I can recognize that I know 10 times 10 equals 100. So the square root of 100 isn't quite enough. If I went to, let's say, 12 times 12, I know what 12 times 12 is off the top of my head. That equals 144. So 144 is not high enough to get to 169. So I'm going to try, this is a guess and check method, 13 times 13. So in order to do 13 times 13, I'm just going to multiply that out. I see that that's 9. This would be 3, 3, 1. This would be 9. That would be 169. And the square root of that then is simply 13. Because 13 times 13 equals 169. So the square root of 169 equals 13. And it's not 169 divided by 13. It's simply stating what two numbers multiplied together will equal 169. And that would be your answer. Letter B, 484, the square root of it. So in order to do that, again, I'm going to look at a couple of things. I know that 20 times 20 equals 400. So it's going to be somewhere around that. I'm going to try 21 times 21. I'm going to multiply those out. I end up with 1 here. This would be 2. This would be 2. That would be 4. This ends up being 1, 4, and 4. That's not quite enough. So let's try 22 times 22. So when I multiply those together, I end up with 4. This would be 4. This would be 4. This would be 4. Add those up, I have 484. And that tells me that that's what multiplied by itself together is the answer. So it is 22 for the square root of 484. So the square root of 484 equals 22. Letter C, 961, square root of it. So the square root of 961. So I'm going to try a couple things. I'm going to go to 100 times 100 because I know that that is 1 with 4 zeros. So that's too big. It's not what I'm looking for. I'm looking for 961. So let's just go one down. Let's go 99 times 99 and see what happens. If I have 99 times 99, This would end up being 81. This would be 81 plus 8 makes 89. This would be 81, carry the 8, plus 81 plus 8 again would be 89. And I add those together, I'd end up with 1, 10. This would be 17, that'd be 18. This would be that. So that'd be 9,800. So this one was 10,000. I was thinking for a second that it was wrong. And it is wrong. So this is way off. My guess and check, I'm looking for 961. So I'm going to go way down. I'm going to try, so it's 20 times 20 is 400. And I see 100 times 100 is 10,000. So I'm going to be way off here. I need to maybe try halfway between 20 and 100, which would be somewhere about, what do you guys think, 60? So let's try 60 times 60 for a second, just see where we're at. If we multiply 60 times 60, we'd end up with this. You'd end up with 36. Carry the 3, that would be 36. Be just that. So we'd end up with 3,600 in this case. So this would be 3,600, which is again way too big. So that's no go. We're only looking for 961. So I'm going to go further, like closer to the 20 this time. I'm going to try, let's try 30 times 30. So I'm guessing and checking 30 times 30. I know that that'd be 9 with 2 zeros. That's closer. Now we're getting in the ballpark there. 30 times 30 is 900. So I'm going to just go a little bit bigger than that. I'm going to try 31 times 31 and see what happens. 31 times 31 is 1. This would be 3. This would be 3 here. And this would be 9. And if I add those together, I'd end up with 1 here, 6 here, and 9. That would get me my final answer. So the square root of 961 is going to be equal to 31. And sometimes that happens. You guessing and checking and you guess way off. That's just how it goes. Letter D. Each of these square roots is between which two consecutive whole numbers? Find the answer without using a calculator. So which two consecutive whole numbers is the square root of 2 going to be between? So the square root of 1 is 1. Square root of 1 equals 1. The square root of 3, or the square root of 4, we know we can do perfect squares here. Square root of 4 would be 2. So we know that the square root of 2 has to be between, well, it's going to have to be between the square root of 4 and the square root of 1. So it's going to be between 1 and 2. So each of the square roots is going to be between those. So in this answer, you would say 1 and 2. So the square root of 2 is going to be between 1 and 2. Because if you guys recognize, the square root of 1 is going to be 1. The square root of 2, the number that you can multiply it by, would have to be between that 1 and the square root of 4, which is, we know as 2. So it's going to be between 1 and 2. The square root of 15. So the square root of, we know the square root of 16 is 4. Square root of 16 is 4. So that means this one has to be between 3 and 4. So this one would be between 3 and 4. Letter F, the square root of 40. So perfect squares, we know that 6 times 6 is 36, and 7 times 7 is 49. So that means that this has to be between 6 and 7. for the two consecutive whole numbers. All right. And that reminds me, going back to letter D here, we'd actually want to have that one be between 3 and 4, because the square root of 4 is 2. So the square root of 4 being 2, yeah, we'd end up having 2 squared would be 4, 1 squared would be 1. So it's going to be 1 and 2. It'll be between that anyway. Letter G, the square root of 60. So the perfect square of 8 is 64. The perfect square of 7 is 49. So this one has to be between 7 and 8 without using a calculator. The two consecutive whole numbers. And the square root of 70. So we're looking for something that's close to the square of, if you took 8 times 8, that's 64. 9 times 9 is 81. So because 8 times 8 is 64 and 9 times 9 is 81, it's 8 and 9 for the consecutive whole numbers. Okay, and then in letter I, if you have the square root of 80, the closest you can get when squaring and getting perfect squares would be 9 times 9, which is 81. But you'd have to go less than that, because 9 times 9 is larger than the square of 8. It'd be 81. So it's larger than this 80. That means your consecutive whole numbers have to be 8 and 9 again for the square roots. Use a calculator to approximate each square root of 2 decimal places, or 2 decimal places. So using the calculator, the square root of 3. So you just hit 3, and then you've got the square root button, and it gives you your answer. So this would be 1 73/100 for letter J, because it says use a calculator. All right, and the letter K, what's the square root of 10? 3 16/100. There's a 2 after the 16, or after the 6, so it's rounded to that. And letter L, the square root of 50 would be 7 7/10. All right. And that's all you have for today. Just make sure you guys look at the lesson and review anything you have. Don't forget to do problems 1 through 30 in written practice. It's very important you do all of the problems in order to understand what you're doing in Saxon math. Have a great day.